Hello everyone. So in this video we will be studying a new topic which is discontinuity. Now, what is discontinuity? So a point A at which a function fails to be continuous is known as discontinuity of a function. There are several types of discontinuity of a function fx at a point A. So we are specially studying first type, which is known as a removable discontinuity. Okay, removable discontinuity. There are two another discontinuities which are to be covered in the upcoming videos. So in this video we will doing the removable discontinuity. Now what is this? So a function fx has removable discontinuity at point A if limit extends to A fx exist but not equal to its functional value. Okay, what does this means? This means that the right hand limit and the left hand limit of a function exists but it is not equal to its functional value. This means ki LHL extends to A fx f is equal to RHL extends to A plus f x is does not equal to f of a. So this is known as the removable discontinuity. All right, so let us take an example to understand this more clearly. For example, you are given with fx is equal to x square minus 9 upon x minus 3. Okay, so we have to find its limit. All right, so what happened if we put, see, this is a continuous function. If we do only x is equal to 3 at point x is equal to 3, this will not going to be continuous. This is very clear because when we put x equal to 3 we end up with having f3 is equal to 3 square minus 9, that's 3 minus 3, which is 0 upon 0 form, which is indeterminate form. So now we know that at x equal to 3 this gives us nothing but the indeterminate form. So we will simply factorize it. Okay, how to factorize it? Let's see. Simple factorization, limit x tends to 3, this will going to be x minus 3 and x plus 3 upon x minus 3, and this will get cancelled. Now you applied the RHL and LHL, you will end up having 6. How? You will put limit x tends to h tends to 0, you have x plus 3, so you have 3 minus h plus 3, this is for LHL, and you have limit h tends to 0, so it is 6, and similarly in RHL limit h tends to 0, 3 plus h plus 3, when you put h tends to 0 you will get 6. Okay, so we see here that this LHL is equal to RHL. Okay, this LHL is equal to RHL, so but this is not equal to the functional value. Okay, so it is, so fx has removable discontinuity. So why it is known as removable discontinuity? Because in this type of function we can remove the discontinuity. Okay, so this can be written as f of x is equal to x square minus 9 by x minus 3 when x is not equal to 3, and when x is equal to 3 we have 6. When x is equal to 3 we have 6, its value. Okay, so let me ask you another one. uh, like suppose fx is equal to sine x by x, and here k, where x is not equal to 0 and where x is equal to 0. So you have to find at what value of k fx has a removable discontinuity. Okay, so at what value of k your fx will have a removable discontinuity, you have to find it. So this can be solved as, you have to simply find the limit of what? Limit of this one. Wait a minute. Okay, so you have to find the limit of the sine x upon x. So limit x tends to 0, sine x upon x is equal to 1. We know this is the formula of limit x tends to 0, sine x upon x equal to 1. Now this is not equal to f of 0. You agree or not? Do you agree? Because when when we put the value 0, we will not get 1. Okay, so because we know that f0 is equal to k and k is not equal to 1 here. So at what value of k fx will have removable discontinuity, that is for all value of k belongs to r minus singleton singleton 1, like एक को हम एक नहीं होने वाला है, ठीक है, तो all the real numbers except 1 हमारा होगा वैल्यू ऑफ k. तो इस तरह से हम ले सकते, तो हम कह सकते हैं कि fx हैज़ अ रिमूवेबल discontinuity.